These are my predictions for paper 2 for the Regional Edexcel IGCSE Chemistry exam 2CR 2025. So the first topic is reversible reaction and position of equilibrium. This is almost a guaranteed topic in your exam. So what are the common type of question that you would see with this topic? So they're going to provide you with a reversible reaction, and it's mostly or all of the time it's a gaseous reaction. So they're going to ask about what is meant by equilibrium. So remember that dynamic equilibrium is reached when the rate of the forward reaction equals the rate of the reverse reaction, and also when the concentration of reactants and products remain constant. They usually ask about the different factors affecting the position of equilibrium and to explain that and how does this change, a particular change, affect the yield of the product. So remember that the temperature will depend on which way or which direction of the reaction is exothermic. So if you increase the temperature, the the equilibrium will be pushed toward the endothermic reaction. So if the forward reaction is ectothermic, the reverse reaction, the equilibrium will be towards the reverse reaction, so decreasing the yield. Concentration in case of solutions, but they usually give you gaseous reaction. So the question will be about the effect of the pressure. So if you increase the pressure, the equilibrium will be pushed to the side, which has less number of moles. So it will depend on any reaction, which one has higher number of moles, whether it's the reactants or the products. If the number of moles of the reactants is the same as the number of moles of the products, then increasing the pressure will not increase the yield. It will just fasten the process and the equilibrium will be reached faster. Use of a catalyst, it doesn't affect the position of equilibrium because it increases the rate of both forward and reverse reaction at the same rate. So typical questions asking you about these arrows and what do they mean. So this means that this reaction is reversible. What is meant by dynamic equilibrium? Very common question, and would give you a certain one of these conditions and ask you how the change in the condition will affect the yield. So you need to think about these one and how they affect the yield of the reaction. Topic 2 is reactivity series and extraction of metals. So the main thing here is about the use of carbon for extraction of metals from their metal ores or from their ores. So metals below the carbon and the reactivity series are less reactive than carbon and can be extracted from their ores using carbon. The role of carbon here is that carbon is a reducing agent, so because it takes oxygen away from the metal ore, or it loses electrons if they ask you in terms of electron gain and loss. Metals above the carbon in their activity series are more reactive than carbon, and they will not be extracted by carbon, but they can be extracted by electrolysis. Remember that the very unreactive metals like silver, gold, and platinum, they are found uncombined elements in nature. They don't need to be extracted. You should be able to write the equation for these redox reactions. Electrolysis, it's always in the exam, never seen an exam without a question about electrolysis. So remember that electrolysis is split by electricity. You use two electrodes connected with electricity outside, and you use an electrolyte. You end up with a negative electrode and a positive electrode. So this is a positive electrode and a negative electrode. There are two types of solutions or two types of electrolytes that can be used. The first one is the molten ionic compounds. So with molten ionic compounds, you have an ionic compound which cannot conduct electricity as solid, because this is a very common question because there are no free ions to move and carry the charge. But in case of molten ionic compound, when molten, they conduct electricity, and you can electrolyze the molten ionic compound. One of the most common ones that come in the exam is lead bromide. However, this is a representative example because they all gonna behave the same. So this is sodium chloride. Here, the sodium ion will move towards the negative electrode. They will lose an electron. They will gain electron, get reduced, and will give you sodium metal. For the chloride, or the negative ions will move toward the positive electrode. They will lose electrons electrons and get oxidized and give chlorine. You should be able to write the half equation and explain why it's oxidation or reduction. Remember oil rig, oxidation is the loss of electrons, so this is oxidation, and reduction is the gain of electrons, so this is a reduction. And then we have electrolysis of aqueous solution, so they could give you something like copper sulfate, or maybe something like even hydrogen chloride. Remember that hydrogen chloride, well, it's an acid, and in aqueous solution, it will ionize to give you hydrogen ion and chloride ion. So when you have an aqueous solution, there is now other things to think about, because now there will be competition at the positive and negative electrode between more than one cation and more than one anion. So we're going to have two different cations here, which are the hydrogen ion from the water, because water is going to split to give you hydrogen ion and hydroxide ion. And we're going to have the anion and cation from the ionic compound. So if we have at the negative electrode, there will be competition between the metal, which is the metal ion, and the hydrogen plus from the water. Metal above the hydrogen in the reactivity series will not be reduced. So if you have a metal like sodium, like iron, like any of these in the electrolysis and the electrolyte, then the hydrogen is the one that's going to be reduced at the negative electrode, and the product will be hydrogen gas. And if the metal is below the hydrogen interactivity series, mostly the copper, then it's the one that is going to be reduced at the negative electrode to give you the copper metal. At the positive electrode, the competition will be between the anion and the OH minus, or the hydroxide ion from water. So if you have a halide, the halide will be oxidized to give the halogen. So if you have chloride, bromide, or iodide, they will give the chlorine, bromine, or iodine. They will be oxidized. But if you have any other anion like sulfate, nitrate, anything else, then it's going to be the hydroxide, where the hydroxide is going to be oxidized to give oxygen. So the product here at the positive electrode will be oxygen gas. This topic, energy level diagram and calculation of the enthalpy using bond energies. This is a typical question in your paper, so make sure you understand this very well. They tend to ask you to complete the energy profile for an exothermic or an endothermic reaction. So let's very quickly go over the basics which you need to answer your question. For ectothermic reaction and the energy diagram, remember that the energy of the product will be higher than, and the energy of the reactants is higher than the energy of the product. And then as the reaction goes, it goes to the top point here and then go down to the energy of the product. You need to label the activation energy, which is the difference between the energy of the reactant and the top point. And then the overall energy change will be the difference between the energy of reactants and product. In exothermic reaction, the reaction will release energy or heat, and there will be an increase in the temperature. The overall energy change is negative value. And then endothermic reaction will be the opposite. So the energy of the reactants is less than the energy of the products. The overall energy change again is going to be the difference between the energy of reactants and products, and the activation energy is the difference between the energy of reactants and the top point here in the diagram. Remember that for endothermic reactions, reaction will take an energy, there will be a decrease in the temperature, the overall energy change of the H will be positive. They will ask you to calculate the delta H from for a certain reaction using the bond energy provided to you in a table. So remember to calculate the delta H. It will equal the energy gained to break the bonds in reactants minus the energy lost to make the bond in products. So it's going to be negative value if it is an exothermic reaction and positive if it's an endothermic reaction. So typical questions is to complete the diagram for a particular reaction and label it to show the difference between catalyzed and uncatalyzed reaction. So remember the difference is that for the catalyzed reaction, for example, if I'm gonna do an exothermic reaction, so this is the uncatalyzed, and then the catalyzed will have a lower activation energy, but the energy of reactants and products will remain the same. and also to calculate the molar enthalpy change using bond energy, something like this question here, and what is meant by exothermic reaction, and asking you to refer to the bond energies in your answer. So you have to refer to the fact that if it's an exothermic, that the energy released when the products are formed and the bonds in the products are formed is more than the energy taken in to break all the bonds in the reactant. So this is the exothermic, and the endothermic will be the opposite. Making salt, again, this is quite common in paper 2. So it's only when you start from two soluble reactants through the precipitation to make insoluble salt. Formation of lead bromide is one of the most common ones that come in the exam. This is another one for lead sulfate. So remember the table for the substance and the soluble and insoluble salts. So as I said, the most common one probably is the lead bromide. It comes from a reaction between a lead salt like lead nitrate, a soluble salt, along with maybe something like potassium bromide that will give you the lead bromide as a solid. Also, sometimes they ask you how to prepare a salt from titration. So if you titrate an acid with a base to make salt and water, then how to make the salt and dry it, get a crystalline salt, clean, dry salt. So also practice this one. So acid-base titration, it's very common in your exam. You should be able to carry out acid-base titration. You should know your steps. You should know your apparatus, the use of pipette, burette, the use of the conical flask for the titration. Why do we use wide tile underneath to just be able to spot the change in the color of the indicator? You should know your indicators. The most common one they ask about in the exam is methyl orange. Remember the color change from alkaline to acidic solution and vice versa. So methyl orange is yellow in alkaline solution and it's red in acidic solution. You should be able to improve a titration method provided to you in the exam. Remember the concordant results, which are the results within zero point 0.2 centimeter cubed of each other when they give you the volume of the titrant or the volume for the titration. So you only use concordant results, which are within zero point 0.2 centimeter cubed of each other. Calculate the concentration from titration. Of course, this is a typical question in your exam, and you will see one in your exam. Moving on to the bonding. So ionic bonding is one of the topics in paper 1. However, it only comes in paper 2 if they ask you about, sometimes when they ask you about electrolysis of molten ionic compound, or if they have this question when they ask you about ionic formula. So the type of question they would ask you is why this ionic compound? They're not going to say that this is an ionic compound, but they're going to ask why it has a high melting point. So you have to refer that it's ionic compound. It has a strong electrostatic interaction between oppositely charged ions, and there's a giant ionic lattice, and then they need a lot of energy to break the bonds. So it has a high melting point. Also, they tend to ask about the conduction of electricity, especially this question comes along with the electrolysis. So why they don't conduct electricity when solid, but conduct electricity when molten or when aqueous solution. It all because of the presence or absence of the free ions. So when solid, the ions are held in the giant lattice. They are not free to move and carry electricity, while they can conduct electricity when molten or dissolved because the ions are free to move. Metallic bonding, it's one of the main topics in paper 2. So in metallic bonding, what do they like to ask about? Remember the type of bond. The metallic bond gets a strong bond. It's electrostatic forces of attraction between negatively charged delocalized electrons and positively charged ions. They tend to ask you about the properties and to explain the properties of the metals. So metals conduct electricity because of the delocalized electrons, which can move throughout the structure and carry the charge. They are malleable, and the malleability because the regular arrangement of the layers, so they can slide past each other or over each other when hammered. Also, they are ductile, which means they can be drawn into wires. Alloys are harder, and they tend to ask you why alloys are harder. So alloys are made up of a metal mixed with another element. The other element could be a metal or non-metal. The other element was going to have a different size of the atoms. So the alloys are harder. They tend to ask you why they are harder because of the different sizes of the atoms. They distort the regular arrangement of the atoms of the metal itself, and making it more difficult for the layers to slide past each other. So this is an alloy, and this is the extra metal that was added. Uses of metals, so not too common in the exam, but just in case what you need to know. Copper, there was a question about why the copper, what properties of the copper make it a good, can be used in wiring. Remember that it can conduct electricity, it has low resistance, and it's ductile. Iron, remember that difference between iron and aluminium. Iron can corrode easily, so usually they would add another element to make alloys which change the properties of the pure metal. So low carbon steel are easily chipped, high carbon steel strong and inflexible, and stainless steel corrosion resistant. Aluminium doesn't corrode because of the formation of a layer of aluminium oxide, which protects the aluminium. Reactivity trends in the periodic table. This is almost a guaranteed question in your paper too. So here we are talking about group 1 elements and group 7 elements. So they either ask you about group 1 or group 7, depending on the context of the question. So remember that for group 1, as you go down the group, the reactivity increases. The reason why is because as we go down, the radius of the atom increase, the outer shell electrons become further away from the nucleus, and that becomes they are less attracted to the nucleus, and they become easier to lose. So the it becomes more reactive. In terms of group 7 elements, reactivity decreases as we go down the group because, again, the same reason. So the radius increases, the outer shell electrons are further away from the positive nucleus, and it becomes harder to gain electron. So for group 1 elements, they tend to ask you about the reaction of group 1 elements with water. The type of question that will come here is either about the observation that you see when you add lithium to water or when you add potassium to water. Remember, the main observations are the fizzing, the floating of the solid gets smaller. In case of potassium, it burns with a purple flame. And then they ask you about the reactivity trend. So for example, they could ask you about lithium and water, and then ask you what are the different observations when we add potassium and why potassium is more reactive. So as we go down, the reaction becomes more vigorous. And this is the equation. Remember, when the metals react with water, they give you metal hydroxide and hydrogen. Sometimes as well, they would ask you what will be the change in the color of a universal indicator when we add it to this solution. So remember, because it's going to be an alkaline solution, or there is a hydroxide ion in the solution now, so it's going to be purple blue. And then group 7 elements, they tend to ask about the physical properties or their appearance. So whether it's a liquid, solid, or a gas, and the color of the different elements. So try to revise these ones. And then in terms of the chemical properties, it's the reaction between the halogens and the halides. So the more reactive halogen can displace the less reactive ones from their salts. So we have, as we said, as we go down, the activity decreases. So the chlorine can displace both the bromide and iodide from their salts to give bromine and iodine, and then the salt of the chlorine. So potassium chloride or potassium, in case of with potassium bromide, will give you potassium chloride and bromine. In case of the potassium iodide, will give you potassium chloride and iodine. Bromine can displace the iodide, but the iodine cannot displace either because it's less reactive. Organic chemistry. So the main topics that are only in paper 2 are the alcohols, carboxylic acid, and esters because they are not part of paper 1. So the most common type of question that come related to these are the manufacture of ethanol, so fermentation of glucose to give ethanol, the product here, and the optimal conditions. So if the fermentation comes, they're gonna ask you about the optimal condition. Remember that we need to do the fermentation under anaerobic condition, absence of oxygen, so the alcohol wouldn't get oxidized to give the carboxylic acid, and also the temperature, which is between the 25-35 degrees, because it's an enzymatic reaction. And then the heat of ethene with phosphoric acid with the use of the catalyst of phosphoric acid as a catalyst, temperature above 300 and pressure 60 to 70. This is not very common in your exam. And then the ethanol oxidation, this is very, very common. So many times in the exam, this question came, oxidation of the ethanol to give ethanoic acid. And this is done by heating with potassium dichromate and dilute sulfuric acid. So they tend to ask you about the two reagents used in the oxidation. So it's the potassium dichromate and dilute sulfuric acid. And then they ask you about the color change. So remember the potassium dichromate, it changes color from orange to green when it oxidizes ethanol. The structure formula of carboxylic acid functional group, it's quite common as well. Remember, this is the carboxylic acid functional group, and they tend to ask you to draw the structure formula for different compounds. It could be for the carboxylic acid, for an ester, or for an alcohol. The reaction between an acid and alcohol to give an ester, also very common. So usually when they ask about alcohol, they can ask about acids and then ask about esters because they are linked. All of them are linked together. So for the esters, they will tend to ask you to name the ester and show the displayed formula for the ester and circle the functional group. So remember, this is the functional group for the ester. And when you name the ester, you name the part that come from the alcohol first, and then you name the part that come from the carboxylic acid. So if you use propanoic acid with methanol, so it's going to be methyl propanoate. Remember the uses of esters. So esters are volatile with distinctive smells, so they are used to make perfumes. The polymers, so condensation polymers is the only type of polymers that come in paper two. It's not very common. I wouldn't be surprised if there was nothing about polymers in your exams. So, but the type of questions that come with the condensation polymers are typical. So they would ask you to write the structure and the displayed formula for the polymer, condensation polymerization, of course, of dicarboxylic acid and diol. So this is the reaction. They would ask you to show the repeat unit or draw the displayed formula of the repeat unit for the condensation polymer. And remember that polyesters are biodegradable. This is why we call it polyesters. Paper, even though the hydrocarbons and fraction distillation of crude oils and cracking are one of the main topics in paper one, but if they didn't come in paper one, expect them to be in paper two because they are very common in paper two, but if they didn't come up in paper one. So you know better than me what was in your paper one. So if any of the following topics haven't been in paper one, expect them to be in paper two. So fractional distillation products and steps, how to do the fractional distillation, the different products, their uses, and all of that. The cracking, conditions of the catalytic cracking and the uses of the cracking products. Substitution reaction of alkanes with bromine under UV light. So to give the halogen alkane and to give the hydrogen bromide. So these questions come in paper two if they were not in paper one. The most common calculations in paper two, delta H, as we said, using bond energies. The volume of gas produced from a reaction. This is a typical question. All these three will be in your exam, definitely. Concentration from titration as well. So remember for the equation that you need to memorize are this particular one here, this triangle that links the concentration to the number of moles and the volume. Remember, when you do calculate the concentration or calculate the number of moles from concentration and volume, you have to use the volume in decimeter cubed. So in the exam, they will always give you the volume in centimeter cubes. You have to convert it to decimeter cube by dividing by 1,000. Remember that number of moles equals the mass over mR. The volume of the gas, so remember that the volume of the gas will equal the number of moles of the gas times the volume of 1 decimeter, volume of 1 mole of the gas, which is usually provided to you in the exam, which is 24,000 centimeter cube. So this is the volume in centimeter cube. Sometimes they give you the volume of the gas and the volume of 1 mole of the gas and ask you to calculate the number of moles. So the number of moles will equal V over the 24,000 centimeter cube. Solubility and solubility curve, it's not very common in your exam. And I think over the last 5 years, it only featured once. So it's not really very common, but just let's go over the basics just in case they decide to ask about this year. So solubility is the amount of substance in gram that completely dissolves in 100 gram of solvent. The solubility change with the increase in the temperature. In case of solids, mainly the solubility increases with the increase of temperature. You should be able to interpret data from solubility curve and calculate the mass that will crystallize when you cool the saturated solution. You should be able to calculate the solubility from the data provided to you in the question as well. As I said, it's not very common, but you need at least to know the basics just in case they decide to put a question this year about the solubility. Chemical tests